This is just an informal video, and the intent of this video is just to show how we could play with these operational or geometric constraints in SimSched to have shapes closer to what we want or what we need in our operations. Or if we don't know exactly what kind of equipment we're going to use in the operations or what kind of flexibility we're going to put in place, we can play with and see what are the consequences in terms of NPV. Or maybe we use another software after SimSched to do some kind of detailed planning. So you need certain shapes in a certain way. So you can play with those shapes around here to deliver something closer to what you need. So I'm going to give just a few examples. I have taken the Marvin deposit and place some constraints like here, some production constraints, just 50,000 million tons per year, and a total of 100 to 120. I'm going just to play a little bit with those constraints. I've already run a few scenarios, and this one, as Marvin has just blocks with 30 meters, 30 by 30 by 30, this would be something, an exercise with 60 meters is something very detailed. So I'm picking some regions because I'm allowing small clusters of blocks and things like that to deliver the solution. So when I do this, you see here I have a set of scenarios that I have run, and they are here in the report on Excel. And this one is this detailed case. I'm not going through all the indicators, but let's see the NPV of this case. All indicators are control, okay, the production, the total production. And here we have this NPV, a billion and 41 million US dollars. And as a result, the geometry we got was something like this. So you see is a more spotted solution. So if we go through the periods, we'll see there are some regions harder to mine and things like that. We're going to see this kind of behavior. We're going to go deeper faster because we are allowing very small bottom widths. We have some mining regions that are small, and so on and so forth. So if you are able to have a very selective mining, this might be good because it has a higher NPV than the other cases. So, but we can play with it. And for example, if I increase these two, if I just change to 150 meters here, just to see the impact of more than doubling both these parameters, the result we get, I think, is this one. You see, we are not losing too much NPV, okay? So this might be something to consider. I'm increasing the geometric, I'm getting better shapes without losing much value. So let's see the shapes for this case. This one, so you see we have more connected regions over time. See, we still have a vertical advance of 6, okay, 180 meters. 6th bench is the maximum vertical advance. You see, this is respecting well. And we see this kind of solution is more connected than the other before. Obviously, things are not perfect, but this clearly shows where mining should go first and later. And if we move forward, we could, for example, do something even bigger. For example, work with 300 meters. In this case, what I did was I left the bottom width with 150, but I left the mining width with 300 meters, just as an example. I doubled the mining width. And as a result, You see, we lose a little bit more of NPV. Now it's more considerable than before. And the kind of shape we got, see that now the regions are much bigger because of we doubled the mining width parameter, and we can see through the periods what happens. Here it doesn't matter, okay? So see, the regions are more connected because I'm requiring bigger regions to be mined together. And actually in the last periods we have a bench by bench, a worst case mining. Okay, but if we come back to the last example of 150 meters for both, notice something that I've done here. I've played with the vertical advance, the maximum vertical advance rate, so that I can't go deeper very fast. I have played with, each bench has 30 meters, so I have played with 180, 150, 120, 90. And in terms of NPV, we see that this was 180. For 150, we lost a little bit. For 120, we lost a little bit more. And lastly, for 90 meters, we lost even more. So this is the expected behavior. We're including more constraints to the optimizer. So it may, in generally, you're going to lose value, okay? So if you come back to the geometries, if I put back here, just seeing like a section view, just to see how the vertical advance rate is playing here. So we see here is the maximum in 6 benches, 180 meters, 150, 120, 90. So we see that it tends to the worst mining case. If the user is requesting something very tight, the software is going to respect this kind of parameter and delivers this kind of solution. So it's up to the user to play with those parameters and deliver a solution that makes sense to him.